Okay, well, welcome back to the shop. We're going to continue on the Rotary Broach project. And here's a actual drawing of the body that we're trying to make. And yesterday we finished boring this pocket for our bearings. You notice that this pocket is canted by 1 degree. And the next part of this project is to create this snap ring groove that will hold our snap rings. There's 2 bearings inside the body, and these are the bearings. This is my thrust bearing, and that's the radial bearing. And both of these will just slide right in here, like so. And the other one will push up against that one, and that'll create our bearing assembly inside the body with the snap ring right there holding everything in place. Now, the chuck, I decided to go with an ER16 collet chuck that fits in this bearing. So you can see that as this assembly comes together, that will be the chuck that will hold the cutter itself. Now, this cutter came with a much longer shank and has been modified to fit the stack height of that bearing assembly. So what we'll be doing next at the mill is creating this pocket. Now, we couldn't just take this assembly that we've created and chuck it in the lathe and cut that ring itself using a grooving cutter, because the whole thing is tipped at 1 degree. So we have to create this snap ring groove at the mill. And the problem is I don't have a boring and facing head. My boring head is just a boring head. So we need to get the cutter down to this groove height, which is 29.5 millimeters from the bottom of the pocket to the height, the top part of the snap ring. In order to do that, we'll lower the cutter into the groove, but then if you turn the mill on, how do you get the cutter to push out and actually create the groove? So what I came up with is we're going to do it manually. So we're going to drop the cutter down into the height that we need, and we're going to rotate the head manually and gradually move that cutter out to create the groove for the snap ring. Now, the snap ring I chose is it's a metric snap ring that was available from MasterCar, and that's what's going in that pocket to hold everything in place. Now, the other part of the project that we haven't talked about is the actual shank that's going to screw into this assembly here to create the part that's held. And here's a drawing of that. Let me zoom out a little bit here. All right, and that's actually this part here. I've already made this. So what we have here is a 1-inch thread going to a shoulder, and the whole assembly is bored out from end to end so that we can insert a pin in here. And there's a set screw at the other end that will hold that pin and actually push the cutter within the assembly that we're now working on, this part here. So you'll have a pin that'll come in from this end, come out to about here in the body of the collet holder, and actually hold the cutter assembly so that it doesn't push up into the bore. Now, that's an ER16 collet holder, and the beauty of this design is it allows you to use cutters of various lengths and whatever you have available to make the cutters, and not worry about the overall length, because you'll have some adjustment at this end that'll allow you to get the cutter to be in focus. I call it being in focus. This is the actual point at which the cutter is going to be not oscillating but kind of pivoting on in like this here as the broach works. So our next step is going to be at the mill, and we're going to go ahead and make this part. So we'll catch you at the mill. Okay, we're back at the mill and we're going to start to create this snap ring groove. What I've got in here now is a high-speed steel cutter that was shaped to a width of 1.85 millimeters, which is the recommended width of that groove. So what I will do is rotate the cutter head and gradually feed in on the OD. And you can see we're forming chips. I hope you can see that. There we got a nice chip going. We'll take our time. And you notice I'm gradually feeding in on my dial here, which is in thousandths on diameter. And we're going to just gradually get down to the required diameter that is specified for this snap ring. As I said earlier, we couldn't do this in the lathe because the bore on this is canted by 1 degree. And consequently, if we did it in the lathe, the snap ring would not sit flush to the bearing itself because it would have been off. Another 2 thou and I think we'll be there. And I'm going to go a little extra. Yeah, just finish it up with it. Clean it up. That looks pretty good. All right. We'll get back to the next phase. Okay, we're back. We just completed the snap ring groove. I hope you guys can see this, but there's a nice little groove in there for our 47 millimeter snap ring. And there's the back side of the body and a thread. And there's the shank for it. That thread's in there. And I'll put the camera down for a second. Needed 2 hands for that one. Alright, there's our completed body. And I'll stand that up. Hopefully that'll stand. And there's our completed ER16 collet assembly with the radial bearing and the thrust bearing. And there's the inner race. I'm not going to assemble this now because one more detail I've got to do on this body is drill a hole through the side and set it up for a grease fitting so that you can grease this radial thrust bearing right here. And then I'll remove the inner seal on the radial bearing so that grease will get in there. And that'll complete the body assembly. So on to the next thing. Okay, there's our completed parts for the rotary broach. Only one detail left to do, and that's put a small hole on the side of the main body of the broach so that we can grease it. And some of you may have been wondering about my setup. This is the setup that I used. I'll put a little light on here. So I've got my sign plate right here, and underneath the sign plate is a stack of gauge blocks to give me the appropriate angle of 1 degree from horizontal. This is just a easy clamp to prevent it from pulling up. And underneath there you can see the gauge box stack resting on the sign plate reference point. And then of course the machinist vise, which I mounted the body of the brooch on. Also, just wanted to point out a detail that I may not have mentioned. And these are the two flats on the side of the body, just so you can wrench off the whole body off of the shank. And that completes our unit. And now, like I said, we just got one more detail to do, and that's the grease fitting. So catch you later. All right, back again. Here's something that I thought you guys want to probably see, and this is the cutter that I used to make the groove for the snap ring. You can see the tool bit right there, and this is a very simple little cutter you can make. It's just a body that's been grooved for a 3/8 tool bit. You can see that. And then the body's cut in half, and a set screw, an Allen wrench screw, is put on the end of it to kind of act like a clamp to clamp the two parts together. Works really well, very quick to do for those oddball kind of jobs you gotta have. But anyway, I thought you'd like to hear that.